let's up our game. We're going to update data in blob storage. I've got a slice in my API, update destination images, which can be used to update a set of images in blob storage related to a certain destination. Now, this is an API endpoint, so the use case is that this will typically be called from a front-end web app, in which, for example, an admin can change the images linked to a destination, after which those are sent as base64 encoded bytes to this API endpoint. The endpoint implementation then needs to ensure that these images are effectively added, updated, correctly tagged, and so on in blob storage. That is what we need to implement. As you can see, all the boilerplate code is here already, but the implementation is missing. To get an idea of how something like that would look, I also included a potential request. So this is a put request to destinations / the ID of the destination, which is 1 for Antwerp, / images. These images to update have a name and a bunch of bytes. I didn't actually include the actual bytes, I just input a string here. So from the moment on we do this, the actual images in our blobs will no longer be images, but this is sufficient for the demo. So what this means is that we can verify that the images are indeed related to the destination, as that destination identifier is a tag on our image blob, in case it exists. And that is necessary, as you don't want to allow a request to update images related to another destination. Imagine that one of the images in images to update is actually an image that already exists with the same name but is linked to San Francisco. You do not want that to be updated. The image name you see here relates to the blob name, so that is actually the way in which we can uniquely identify something in our blob container. And that is why it's so important to check the destination ID against the identifier tag. Anyway, so the boilerplate code is already there. Let's implement this. When the request comes in, I already ensure that the correct destination ID from the URI is used, so that's okay already. And we eventually then end up in this handle method here. The first thing we're going to need is a blob service client, so let's inject one and let's assign it to a field. There we go. In the handle method, we create a blob container client just as before. I can, in other words, simply copy this. Then we run through each image to update and try to get related blob. These images can be found in the incoming request. The images to update array is what contains them. So for each of these I get the blob. We also know how to do that via a blob client. There we go, a blob client for one specific blob. The first thing to test is whether or not this already exists, because if it doesn't exist yet, we want to add a new blob. So if it doesn't exist yet, and of course we pass through the cancellation token, we need to create the image and then add the tag. To upload the blob, a convenient way is using a memory stream. So let's do that. I new up a memory stream over the incoming bytes of one of the incoming images. And on the blob client, I then call upload async, passing through the memory stream as first parameter, and a set of blob upload options. This is important because we want to set the tag as well. The destination identifier tag must be set to the identifier of the current destination. Blob upload options is defined in azure.storage.blobs.models, so let's import that namespace. And on it we can set the tags. It's a dictionary of string. As key, I pass through destination identifier. And as value, the destination ID from the request. And here too I pass through the cancellation token as a good practice. There we go. If it already exists, we have a little bit more work. We need to validate the tags first. So first I need to get the tags of the blob. For that too, we can use the blob client. Get tags is the method we're looking for. Again, passing through the cancellation token as a good practice. And then we must check if the blob has a tag with key destination identifier and value request.destination ID. So we try and get a value for something with key destination identifier. If the value can be found, we check if it is the same as the destination ID of the incoming request. That's the condition. That must be true. If that is true, the blob has the desired tags, so we can perform further actions. We call upload async, passing through the stream again, the upload options with the tag and the cancellation token. That is actually the same as before, so I can copy this. Important here is that we also pass through the tag again, because when we override a blob, the tags are overwritten as well. So if we don't set a tag, there will be no tag anymore. If there is no destination identifier, we don't really have something to do. We cannot correctly verify whether we want to update the blob or not. So there must be some sort of error handling here. We could, for example, say that we want to log this, throw this, etc. That's something that has to be decided. For us, however, this is sufficient. Let's just make sure that this compiles, and let's give this a try. All right, let's first have a look over on the portal. We've got Antwerp and Antwerp 2 here, modified at 325. Let's see what happens when we send our request. We get back a 200 OK. That looks fine. Let's have a look over on the portal, and let's refresh this. And what we see here is that the Antwerp blob has been updated and that a new blob has been added. There we go. Our logic works. So this is how you can write to blob storage, either updating or creating a new blob. Up next, queue storage. Previously I've shown you how to work with blob storage and table storage, mainly using the portal and storage explorer. For queue storage, I'm going to take yet another approach. I'm going to use the Azure CLI to create a queue. I've opened the PowerShell prompt and I've executed the AZ login command, so I'm logged in. The command to deal with Azure storage is AZ storage. If we add --help, we can see all the commands we can use. Through this, we can manage all types of storage, also table and blob storage. I'm interested in queue storage, so what I'm looking for is the AZ storage queue command. Let's add --help here. And we can see that via this we can create a queue, delete one, check if one exists, and even generate a shared access signature if needed. What we want to do at this moment is create one. We pass through the account name, app dev st dev we travel, and we also pass through a name for the queue. Image message queue, for example. I could have provided a connection string, account key or token here, but seeing I am logged in via AZ login, the CLI is smart enough to try and fetch the authentication info that is required to create the queue. Let's verify if it was indeed created. We can do that with a list command, passing through the account name of our storage account, so app dev st dev we travel. And we indeed see that we now have one queue here. So that's it already. The queue has been created and we have verified that fact. We can now put messages on it and read messages from it. So let's do that next. Imagine that our API isn't the only one running in the application landscape. Others exist that also use images from blob storage. Imagine, for example, a service that reads images from blob storage and auto-generates static reports, documents or gallery pages from them. Whenever a new image gets added or an existing one gets updated, that service should process it. That's where queue storage comes in. We can, when an image gets added or updated, put a message on the queue. Another service can then pick up that message, for example, a service that generates those reports. This type of scenario, by the way, is quite typical in a microservices environment, where those microservices often have their own data stores that may contain duplicated data from other data stores. So if something changes in one store, they need to be notified of that so their data store can be put in sync. But anyway, let's implement this scenario. We're going to need the azure.storage.queues package for that. So let's install it. There we go. This one exposes a queue service client. Let's register it, just like we did with our table service client and blob service clients before. So I can simply copy paste this. The connection string is still the same. It's the same storage account, so that remains as is. The only thing I need to change here is switch this to a queue service client. And that is defined in azure.storage.queues. All right, I can now inject this. So in our update destination images command handler, let's do just that. Now let me store that in a field. In the handle method, I can now create a client for our image messages queue. As you notice, working with this is much like working with the blob service client or even with the table storage client. So once you get used to working with one of these storage packages, learning how to work with one of the other ones is quite easy. Anyway, we've got a queue client that allows us to integrate with our image messages queue now. Right after we have uploaded a previously non-existing blob, we want to send a message. The code to upload that is here from a previous demo. So all I need to add here is sending the message, so putting the message on the queue. For that we use that image services client, but first we need to create a message. What we want to send needs to contain enough information for the other service, the thing that will pick this up, to do something with it. An action, for example, say image blob created and the name of the blob. So the other service or endpoint or whatever's gonna pick these messages up can identify and fetch the blob and do something with it. So let's say that the action is named image blob created and the blob name is, well, the name of the thing we just uploaded. To interact with the queue, we use our image messages queue client we just created. On this queue client instance, we can find methods to clear messages on the queue, delete them, peek or receive them, and send them. And that's the one we need. So let's do that. And as a message, I pass through the serialized message variable. So we use the built-in JSON serializer for that. And as a good practice, we also pass through the cancellation token, of course. This is an async call, so we also need to await it. That's it for a new blob. When we update an existing blob, we want to do something likewise, but the message is slightly different this time. The action name is not image blob created anymore, it will be image blob updated. So I create a message again, and then I send it. That's the same code as I used before, so I can just copy this over. And there we go. That should be it as far as putting messages on the queue goes. Let's give this a try. Let's send a request to update images again. That seems to have worked. Let's switch over to the portal and let's have a look at our message queue. So I navigate to the storage account, open the queues blade, here's our message queue, and there we go. 2 messages together with an insertion time, an expiration time, and a dequeue count. That's the amount of times the messages has been dequeued, which for now is 0. Up next is handling these messages.